Okay, so let me give you the skinny on these friction problems, right? The first thing you want to do is figure out the force of friction. So the force of friction is going to be mu times m times g, and that's because this is a level surface, and it's mu times the normal force. And the force holding these two surfaces together is just the weight of the object. There's no trickery there. Okay, so that's the first thing to do. And then the second thing you're going to do is we're going to set up F equals ma, right? So F equals ma looks like this, though. Okay, you're going to have some applied force. I'll just call it Fa, right? Read the problem. The problem, okay? Strictly speaking, if it's to the right, make it positive. If it's to the left, make it negative. Okay? Just read the problem. Don't worry about which way the block's sliding. Okay? Don't do anything like that. Just if it's right, make it positive. If it's left, make it negative. Okay? Then you've got the force of friction. And that can be either direction too. Okay, so positive is to the right, negative is to the left. But just remember that the force of friction always opposes the slide. So for example, if this guy's sliding to the right, the force of friction will be to the left. And if you've got an object that's sliding to the left, whoops. If you've got an object that's sliding to the left, the force of friction will be to the right. Okay? So the force of friction always opposes the slide. Okay, so if you're sliding right, write this down. This is your guide. If you're sliding right, then friction is left. And you use a negative for that, right? If it's sliding left, then friction is to the right. And you're going to make it positive, okay? You got to do it. You got to think about it. The applied force is either to the right or the left. The friction force is either to the right or the left. And it's always opposite the sliding direction. So just read the problem, right? And then this equals m times plus or minus a. Well, this is problematic too, right? So positive, if you think about this, positive acceleration is sliding right and also accelerating, that is speeding up. When I say accelerating now, I mean just actually going faster and faster, right? But you could also accelerate positively if you're sliding left, but decelerating, okay? So by accelerator, I mean going faster. By decelerating, I mean going slower. Okay? So that's the two ways that you can have a positive acceleration. Let's see. Hold on. I can do this. Okay? Negative acceleration is sliding left and accelerating, obviously. Right? That is going faster, right? Okay, but you could also have a negative acceleration if you're sliding right, but decelerating. And by decelerating, I mean going slower. Okay, so this is a tricky, worthy, hard, difficult problems. Okay, you've got to look at the accelerations, decide whether they're positive or negative. That is, by these rules, right? You've got to decide which way it's sliding. That determines which way the friction is. You got to read the problem and look at the applied force. So we're going to just work through some of these problems. And I think if you do enough of these things, it's really not that hard. You just have to practice, right? You got to practice Newton's second law.